Welcome all to the BKR chemistry classes. In the previous video, we have seen the Favorskii rearrangement. Today, I'll be discussing upon the Quasi-Favorskii rearrangement. Quasi-Favorskii rearrangement. Quasi means it is Favorskii type, similar to Favorskii. So, in this particular rearrangement, the starting material is slightly different. So, we start with either alpha alpha dihalo ketone, or we take up alpha alpha prime dihaloketone. Let me take the example of alpha alpha dihaloketone. So CH2 C double bond O CH Br Br. So this is alpha alpha dihaloketone. The next case alpha alpha prime. You have the halogen on the either side of ketone. Now, in this case, the mechanism will be subtle different from the previous Favorskii mechanism. Let us see. Let me take the alpha alpha dihaloketones. Same as the previous one, you take the base sodium ethoxide. You'll be having deprotonation, formation of carb anion, formation of carb anion. Then you'll be having the intramolecular nucleophilic attack, relieving one of the Br, resulting in the formation of the cyclopropanone intermediate. So here I'll be having one Br left. On this side I'll be having the phenyl ring. So the difference is, in the previous case we didn't have the halogen in the cyclopropanone intermediate in the Favorskii rearrangement, but here we have the halogen. The next step, as same as before, I'll be having the attack of the sodium ethoxide, attack of the base. So the OET minus will attack the cyclopropanone intermediate, resulting in the formation of the tetrahedral intermediate. So I have a CHBr here, and I have a hydrogen and a phenyl ring on the other side of the cyclopropane. Okay. Now in the previous gate, what we saw is that when this O minus reverts, I have cleavage of the either side of this or this side of cleavage. Okay, so I have shift of electrons like this or like this. But now the scenario is slightly different here. The scenario is slightly different. So what exactly happens is, when this O minus reverts, the CC bond shifts in such a way to eliminate the Br. So as a result, you have formation of a double bond. You can see your formation. So this bond is shifting here. So you have a formation of double bond, and Br has got out. Okay. So I have a C double bond O, OET, and this carbon is attached to the carbon containing the halogen, but the halogen has gone out. And now this has become the double bond, and I have a CH phenyl ring. So what I get is, from this ester, this is alpha carbon, beta carbon. So I have alpha, beta, and it is ethyl cinnamate. Ethyl cinnamate. So you can see the cause of reaction is very different in quasi-Favorskii rearrangement. You have a total turnover in the progress of the reaction, whereby you get an alkene containing ester. Suppose I take the alpha alpha prime, alpha alpha prime, alpha alpha prime. Let us see what is the case there. Alpha alpha prime. So when I take the base, I'll be having preference in the formation of carbanion. Then the attack of the carbanion to relieve one of the Br, giving you the cyclopropanone intermediate. So here the carbon of one side contains CH2, the other side contains the bromine and benzene ring. Now the attack of OET minus to the carbonyl carbon, resulting in the formation of the tetrahedral intermediate. So as I told already, so when this O minus reverts back, the shifting of bond is such a way to eliminate the Br. So I have COOET, and since this bond has cleaved, and the carbon is attached to the carbon containing phenyl. You have the double bond, and you have the CH2. You can see I get an alkene, but here also I get the alpha beta unsaturated alkene, but I get a total different ester. So whether I start with alpha alpha dihalo or alpha alpha prime dihalo, I get alpha beta unsaturated ester. So in Favorskii, we got ester, but in Quasi-Favorskii, we are getting unsaturated ester. So this is the difference between Favorskii and Quasi-Favorskii rearrangement. So based on this Quasi-Favorskii rearrangement, we can attempt a question which was asked in JAM 2022. So you can see this is alpha prime dibromo. So in this particular case, we know that this becomes a Quasi-Favorskii rearrangement. So Quasi-Favorskii rearrangement gives rise to unsaturated ester. Now look into the four option. This is not at all ester, so it's totally ruled out. This is not unsaturated. This is also not unsaturated. This is not at all ester. So the only unsaturated ester given is option C. Therefore, C is the answer. Straight away, we didn't do any mechanism, nothing. We have straight away we have got the answer. Very simple. So if you study the mechanism in detail, you can surely get to the right answer in no matter of time, very quickly. But let me do this rearrangement for you people. So I have Br, the gem dimethyl group, and CH2Br. Okay. So I take sodium ethoxide. So since this carbon does not have an hydrogen, so obviously this carbon will be relieved of the proton. So I'll be having, see how beautifully they given the question for you to have a clarity in mechanism. So minus. So now you'll be having internuclear intramolecular nucleophilic attack, relieving the Br. So I'll be having formation of an cyclopropano intermediate, which is of this kind. So I have a Br here, I have an hydrogen. Now I will attack using the OET minus. You know all this, you know all this very clearly. So maybe you're not looking into what I am doing, you can do it yourself. So you can do it yourself and find the product. So now when this reverts back, we should make it a point that the Br should go out. The shifting of bond should be such a way that the Br goes out. So what I get here, I get COOET, then I have the CH, I have the double bond, and I have the carbon containing the two methyl gem dimethyl group. So CH3, CH3, C double bond CH, COM. So sorry, here they have taken methyl. So let me change that as methyl. So I've taken here ethyl, so it is methyl. Very obvious. So the product is option C. Product is option C. I need not do the mechanism. All that stuff is not required. Just by looking into the Quasi-Favorskii conditions, I know that I should get an unsaturated ester. So straight away land into option C in matter of seconds. Thank you so much. If you have any doubts in this particular mechanism, you can post that in the comment section. Favorskii rearrangement link is in the description. You can watch that if you have not watched it. If you want me to teach any other concept, you can always post that in the comment section. Thank you so much for watching the video. Kindly like the video, share and subscribe it.